Let's apply what we have learned so far. To do this, we'll solve a few example questions. I think like 4 of them. So here is the first one. So it says, to find the height of a tree, a person walks to a point 30 meters from the base, and then she measures an angle of 57 degrees between the line of sight to the top of the tree and the ground. So that this is 57 degrees. So find the height of the tree. So let's suppose this height is some distance h. So how can we find this height? We know that the tangent of an angle is the opposite over the adjacent. So the tangent of 57 degrees is going to be the opposite, which is h. Note h here is not the hypotenuse, it's the height of this tree, divided by the adjacent side, which is 30 feet. So you need to see the right triangle here, right? This is the opposite side, this is the adjacent side, and this is the hypotenuse. So some basic algebra here then gives us that h is equal to 30 times the tangent of 57. So h then gives us approximately 46.2 feet. Alright, so let's look at the next question. So we're given this figure and asked to find the length of this side. So how can we do this? Now this entire figure here may not be a right triangle. In fact, it's not a right triangle. However, we can see two right triangles in here. So we can use the fact that we have two right triangles in here then to first find this side, A, which is from here to here, and then this side, which is B. And then of course A plus B is X. So how can we find A? Well, we recognize again that the tangent of 36 is 85 over A. So tangent of 36 is equal to 85 over A. A gives us then 85 divided by the tangent of 36. Likewise for this side, I know that the tangent of 50 is equal to 85 over B. And so B then becomes 85 over the tangent of 50. X is A plus B, and so then X, this is 85 over the tangent of 36 plus 85 over the tangent of 50. So we can take out common factor here, 85, and then this becomes 85 times what? 1 over the tangent of 36 plus 1 over the tangent of 50. So this gives me here 1.376 approximately, and the other one 0.839. 1.376 plus 0.839 is 2.215, which means then that X is 188.275, 188.3 more or less. Alright, so again, we didn't need to go through all of this. We could have just evaluated this, gotten the number, evaluated this, gotten the number, and added them. Anyway, so the main thing here is a strategy, right? To find this value X, we found A, and then we found B and added them. And A was, we were able to find A because it's the adjacent side of a right triangle, and likewise B. And so we use the tangent function to find them. Alright, so let's look at the next one. Once more, we are asked to find X. So, if you notice here, we have a big right triangle, and then here we have a smaller right triangle. So we can use these two right triangles to find X by first finding the length from here to here. Let's call that distance A. So that distance like that, let's call that A. And then this distance right from here to here, let's call that B. And then once we have A and B, we know that X then is going to be equal to A minus B. So let's find A. To find A, we make use of the fact that the tangent of 35 is equal to 115 over A. So A is simply 115 divided by tangent of 35. That gives us a value for A of 164.224. Now let's find B. Well, we know the tangent of 56 is equal to 115 over B. B then is equal to 115 divided by tangent of 56. So approximately B is going to be equal to 77.57. And so X is going to be 164.24 minus 77.57. That gives us 86.67. there is a lightning rod on the top of a building. From a location 500 feet from the base of the building, the angle of elevation to the top of the building is measured to be 36 degrees. From the same location, the angle of elevation to the top of the lightning rod is measured to be 38 degrees. Find the height of the lightning rod. So let's try and get this by first making a little sketch of what we have here. So this is our building, and that's the lightning rod. So we're 500 feet away. So let's say that's 500 feet away. Then the angle of elevation to the top of the building is 36 degrees. So this angle in here is 36 degrees. And then to the top of the lightning rod, it's 38 degrees. What we want to find is this height here, the height of the lightning rod. So this distance here is x. Well, to find x, all we need to do is find the height all the way up here. Let's call this a, and then this height here, and we call this b. And once again, x is a minus b. Notice there's a common theme running through these problems. So it's very important that you notice these things. So this angle in here is 36 degrees, but this big angle here, well, that's 38 degrees. So let's find these. Let's find a and b. So the tangent of the tangent of 38 degrees is a over 500. So this means that a is equal to 500 times the tangent of 38, which gives us 390.64. And then the tangent of 36 is equal to b over 500. And so b then is equal to 500 times the tangent of 36. And we have that b is 363.27. So x is going to be equal to 390.65 minus 363.27. That gives us 27.38 feet. Okay, so that's it for this video. Bye.